In this video, we are going to be considering the number system. So in the number system, we are going to be looking at real numbers, and we are going to be looking at operations with real numbers, and we'll be discussing absolute value of real numbers, and then rounding up with complex numbers. So let's jump right into it. So let's look at let's talk about this now. When we speak of real numbers, we are referring to a universal set of numbers. All numbers are called real numbers except for complex numbers. Complex numbers are a set of themselves. So when we speak of number system, we consider a tree, like something like a family tree, a number family tree, where we have real numbers, right, and it's represented as this. Then from real numbers, we have another set of numbers referred to as complex numbers. We have another set of numbers referred to as complex numbers. And complex numbers are represented by letter C, capital letter C, this way. Then from real numbers, I said earlier on that real numbers are the universal set of all numbers except for complex numbers. So inside real numbers, we have what we call the rational numbers. We have the rational numbers, which is represented as letter Q, and we have the irrational numbers. We have the irrational numbers, and then under the rational numbers, we have integers. We have integers and we have non-integers. Alright, non-integers. We have integers, we have non-integers. So, and then under integers again, right? Let me take this way. Sorry. So under integers, we have negative integers, and then we have natural numbers. Well, we have negative and positive. Let's say negative and positive integers. Integers is represented as letter Z, this way. And then under this, right, negative integers, we have 0 and negative numbers. The under positive integers, we have natural numbers. Natural numbers, which are the number counting numbers 1, 2, dot, right? Not even to n. It's an infinite set, right? So this could be what we consider as a family tree of numbers, right? So from here you can understand that from natural numbers up, all of them, they are under the real number. Real numbers. So it means natural number is a real number, integers are real numbers, rational numbers are real numbers, irrational numbers are also real numbers, right? So let's look at what we have here. Now when we speak of natural numbers, we are speaking of normal counting numbers. And before the normal numbers that we have, we have Roman numerals, which is I, right? I, right down. These were the numbers that we use for counting, for normal counting. So you could also refer to these numbers as natural numbers, as natural numbers. So when we speak of natural numbers, basically we are talking about normal counting numbers from 1 to infinity, right? So it is also important to note that the sum and product of any two natural number is also a natural number. What this is saying is, if you pick two natural numbers and you add them together, the resulting solution is going to be a natural number. And if you multiply those two natural numbers together, the resulting solution will also be a natural number. So for instance, if you pick 2 and 3, right, 2 plus 3 is equal to 5, which is element of a natural number. And then if you do 2 times 3, this is equal to what? 2 times 3 is equal to 6, which is also an element of a natural number, right? So that is what that means. If you pick two natural numbers, you perform addition on them and then multiplication, the result is also going to be a natural number. So unlike the natural number which form positive integers, we also have negative integers, right? We have negative integers. For instance, you have a solution of this form: a plus b equal to x plus b equal to a, right? And you have to find the value of x. X is going to be equal to what? A minus b, right? Something like this. So, and then we speak of negative integer, which means they are negative. Minus 1, minus 2, minus 3, minus 4, minus 5, like that. Downward is what we refer to as negative integers, right? And then integers generally are divided by 1. But when we get to rational numbers, I believe we are going to get back to that so that you will understand more clearly, right? So this is the set of negative integers, right? So all of these, minus 1, minus 2, minus 3, all of those are integers, but they are negative integers. So when we speak of rational numbers now, we are referring to fraction. When we speak of natural number, we are referring to fraction, where you have a numerator, right? You have a numerator and you have a denominator, and the denominator must not be equal to 0, right? For here now, if you have a solution of this form, a system of linear equation of this form, x is going to be equal to what? A over b, where a can represent any number, b can represent any number except 0. So b must not be equal to 0. If b is 0, it means the equation is undefined, the solution is undefined, right? The denominator is undefined. So b must not be equal to 0, right, for rational numbers. So a could be minus 2 divided by 5, right, like that, and it could be anything at all except for 0. So when we speak of integers now, this statement is very important. The set of integers is a subset of rational numbers, since integers correspond to rational, right? Rational number where b is equal to 1. So we have x equal to a over b, right? This is a typical rational number. So they say when x is equal to a, divide by when b is equal to 1, divide by 1, right, which is equal to what? A. So if we see for integers now, all integers are not fractions, right? Integers are not fractions because they are divided by 1. All integers are divided by 1, that's why they are not fractions. So at the point where b is equal to 1, such a solution is going to be an integer, it's going to result to an integer, right? So this is the same thing as a, which is an integer, right? So that is what this is trying to explain. So let's look at another concept, which is the irrational numbers. Unlike the rational numbers, when we see numbers represented in a short form, right, things like root 2, you see pi, you could see 2 root 2, you could see root 3, root 5, right? But root 4 is the same thing as 2, so this one is not um, it has a lower, you can simplify it further, so you cannot categorize this, right? Numbers that cannot be simplified further but can only be left in short form this way are what we refer to as irrational numbers, right? So on a more generic term, the set of rational and irrational numbers are called the set of real numbers. Remember from our family tree, right? You see that this side we have rational numbers, this side we have irrational numbers, which means everything under rational number here, all the integers, natural numbers, non-integers, they fall under rational numbers. And then, on the general form, rational numbers and irrational numbers are subset of real numbers, so um, they fall under the real numbers. So that's what that statement is trying to say. And if they give you something like this, say you have root 8 to simplify, you know that this is going to be, remember, check our videos on salt so that you know how to simplify this very well. This is 4 times 2, right? So this is going to be root 4 times root 2, which is going to be equal to 2 root 2, right? So these are many more we have done already, so just check out our video on swords and you are going to see it further. So next we are going to be looking at some operations on real numbers.